Use of holdover times. Holdover times for the fluids are derived for each specific fluid brand under various temperatures, fluid concentration, and precipitation category. Note that the lower limit of the published holdover time is used to indicate the estimated time of protection during moderate precipitation, and the upper limit indicates the estimated time during light precipitation. Heavy conditions are not covered. Therefore, crew experience and airline orientation is required to clearly settle what is heavy, moderate, or light. It is very important to determine the appropriate holdover time for the prevailing environmental conditions and apply them on the line. Holdover times should be seen as rough approximations. They simply reflect the average estimated time an anti-icing fluid should prevent the formation of frozen contaminants on the protected surfaces. Actual holdover times can be reduced or extended due to many factors influencing fluid effectiveness, such as high wind velocity, jet blast, heavy precipitation rates, or high moisture content. Recommended practice is to use holdover times in conjunction with a pre-takeoff contamination check to ascertain that frozen deposits have not started to accumulate on treated surfaces. For practical results, the holdover time must be equal to or greater than the estimated time from start of anti-icing to start of takeoff based on existing weather conditions. De-icing and anti-icing procedures. Application of de-icing and anti-icing fluid must be done by trained and qualified personnel. It is the pilot's responsibility to decide whether or not to accept the aircraft for flight. Therefore, it is essential that pilots understand not only how the fluid works and how it is applied, but also the flight crew must be able to determine if the aircraft is safe for flight following treatment. De-icing is required to clean aircraft surfaces contaminated by ice, snow, frost, or slush. Anti-icing is required to prevent ice accumulation. If both anti-icing and de-icing are required, the procedure may be performed in either a one- or two-step process, depending on weather conditions, available equipment, available fluids, and the holdover time. In two separate steps, the airplane is first de-iced using heated water only, or a heated mixture of de-icing fluid and water. After completion of the de-icing operation, anti-icing is performed with diluted or undiluted anti-icing fluid. The second step must be applied before residual liquids from the first de-icing step freeze, typically within 3 minutes. This is especially important where only heated water is used to de-ice. Mixing fluids in a two-step procedure may only be performed if approved by the fluid manufacturer. It is important to keep in mind that in a one-step de-icing anti-icing procedure, holdover time starts to run from the beginning of the procedure. With a two-step procedure, the holdover time starts to run at the beginning of the second step. Under no circumstances should an aircraft that has been previously anti-iced receive a further spray of anti-icing fluid directly on top of the anti-icing contaminated film. If an additional protection is necessary before flight, a complete de-icing anti-icing procedure must be performed. Residues from previous treatment must be flushed off first. Embraer only recommends the use of fluids documented in the aircraft maintenance manual. All fluids must be used in accordance with the manufacturer's recommendations. Ground de-icing strategy. The flight crew must understand the overall de-icing and anti-icing strategies and ensure that the procedures are performed properly to assure themselves that they have a safe aircraft for flight. All soft snow can be mechanically removed by using brooms, soft hand scrapers, or rubber scrapers. Do not use tools to scrape or scratch compacted snow from the airframe surfaces or from the gaps between fixed or movable surfaces. Flaps should be up and ailerons in the neutral position. Parking brake and gust lock set. Setting pitch trim to at least 4 degrees nose up will help in removing contaminants. All doors should be closed. For effective de-icing, the following guidelines are recommended. Wings stabilizer. Spray from the tip inboard to the root, sweeping from the leading edge in the aft direction. No frozen contamination is allowed on the wing upper surface or the horizontal stabilizer lower surface. Vertical surfaces. Start at the top and then work down. The rudder should be in a neutral position. Fuselage. Remove all snow accumulating on the nose to avoid snow blowing back during takeoff and restricting pilot's visibility. Fluid should be sprayed along the top center line of the fuselage and then outboard, letting the fluid cascade down and across the windows. Fluid must not be sprayed directly onto windows and window seals, doors and door seals, air conditioning scoops, or NACA air inlets. A thin layer of hoarfrost on the fuselage is permitted, but only to the point you can still see the aircraft markings. Landing gear and wheel bays. Application of fluid in this area must be kept to a minimum. Do not allow water or fluid mixture spray on wheels and brakes. For this part of the aircraft, it is preferable to clear snow or slush using a brush. Engines. Deposits of snow should be mechanically removed from engine intakes using either brooms, soft hand scrapers, or rubber scrapers. Frozen deposits adhering to either the lower surface of the intake or to the fan blades should be removed by applying hot air or by using a gentle fan spray of heated de-icing fluid. To ensure the safety of ground personnel and passengers, this should be carefully coordinated with the flight crew. It is also important to examine and remove all ice attached to the surface close to the pivot and static sensors, static ports, TAT probes, AOA sensors, and ice detectors. However, de-ice or anti-ice fluid should not be applied directly to these devices. The fluid should be sprayed along the top of the sensors, allowing the fluid to cascade down across the sensor and de-ice it. Ground anti-icing strategy.